Now, let's assume we have got a continuing from the same. We have got a statement 2x1 plus 4x2 and is equal to 7, and we have got 2x1 minus 2x2 is equal to negative 2. Now, looking at this, we can be able to represent them using matrix as follows. So I'm going to take values and put them like that, and then 7, 2. So this one is a matrix that we can have. So that it's like I've pulled up. Now, looking at the law where we are multiplying this by that, we can get that. And if you take this by that, you can get the bottom one. But now we can represent this in this particular matrix. So if I want to get the solution for this, x1 can be equal to the following statement, where I can get, if I do this, it means that I want to get the determinant. So I can get determinant of 7, 2, 4, negative 2 over determinant of the denominator, which is equal to determinant of 2, 4, 2, negative 2. I can get that determinant. Now, whereby x2, I can get the solution from x2 of 2, 2, 7, negative 2, and then the denominator, I can be able to get 2, 2, 4, negative 2. So can you see the way it is? So in short, this is like x is 1 is equal to determinant of a when x is controlled. I mean when the solution is controlled as that. So we adjust and then put determinant of a at the bottom, and then when x1 is controlled, and then you actually say determinant of a when x2 is controlled over determinant of a. So this give you the solution for x2. So what happens in this case is if you want now to get the solution for like the top one, so you can just multiply. So you just multiply 7 multiplied by negative 2 in bracket minus negative 2 multiplied by 4, and then you actually divide this one by negative 2 multiplied by 2, and then you subtract 2 multiplied by 4, so that at the end of the day you are able now to get this one negative 14 and then plus 8 over negative 4 minus 8, so that when you simplify you can actually get the values which is equal to negative 6 on that one, and over negative 12, so that in the process for this one you are getting now x as a half is equal to x1. So that's the way, and then you can use the same to get the value here, so that now you are able to get what actual value can you get. So in the process, if you simplify that, you can get x2 is equal to 3 over 2. So that's actually how we look at problems in that particular way. And on the other part, now you can be given even a statement which can be given as say 2 a bracket b plus beta 1 close bracket and q1 d and d plus b q2 d is equal to a minus alpha 1, and then you can be able to get another one b q1 and then D plus 2 bracket B plus B2 close bracket Q2D is equal to A minus alpha 2. So in this case, you can be able to get the matrix, to the determinant of the coefficient matrix. So a coefficient matrix in this particular part, so you can actually see what is common in this part is this. So is Q1 and this is Q2. So it means that if I can get the coefficient matrix for that expression is equal to 2 bracket B plus B1, and then the other part is going to be B, the other one is going to be B, like that, and the other part is going to be 2 bracket B plus B2, and then the other part is now the solution matrix. So in the process, you can now, if you can get, you can actually say, what about the determinant of this? So you multiply this times that minus this times that, so that in the process, if you multiply the two, it will be 4 bracket B plus B1, okay, multiplied by B plus B2. So you have multiplied by 4, and then you can multiply this and that, remove, so it will be B squared. So this is going to be the date of this particular matrix. So provided that the denominator is not equal to 0, then you can be able to determine the values of this particular solution. So in this case, you can actually say, what about Q1D? So Q1D is going to be equal to the modulus of this one, A minus alpha 1, then A minus alpha 2 divided by, let me take this out, multiplied by B, like the way we did B, B over 2 bracket B plus B2, like that, over determinant of this one, which is like your matrix, bracket B plus B1, B, determinant of B, 2 plus B plus B2, like that. And similarly, you can now take Q2D. So you take this part, now it can be Q2, it can now be equal to 2 bracket B plus B1, B, and then it will be alpha minus alpha 2 over alpha over A minus alpha 2. So you take this one like that, and then you take this, let's assume this is equal to A, you divide this one by A. So this is actually the solution in a macro level environment. So that's how we can be able to find the determinant of this particular problem. So this process is actually regarded as the matrix, the determinant method. Now sometimes we can be able to solve the same using another technique. That particular technique is actually regarded as Cramer's rule, and in terms of the Cramer's rule, we normally can be able to solve it in a different approach, which is what we are going to do next. So we will look at it from a Cramer's